22f1fa11, line 22f1fa19a11, little red spot, Ganymede, solar storms, Jupiter, Wow Seti. Wow Seti, 1977 alien radio signal. I'm going to Google Ganymede solar storms to see if they exist. Quote, water vapor exists deep below and can sometimes be seen through clear spots in the clouds. The planet's stripes are dark belts and light zones created by strong east-west winds in Jupiter's upper atmosphere. Dynamic storm systems rage on Jupiter. The Great Red Spot, a giant spinning storm, has been observed since the 1800s. In recent years, 3 storms merged to form the Little Red Spot, about half the size of the Great Red Spot. solarsystem.nasa.gov. So I'm going to Google Little Red Spot. Quote, Jupiter's Little Red Spot growing stronger, 10-10-06. The highest wind speeds in Jupiter's Little Red Spot have increased and are now equal to those in its older and larger sibling, the Great Red Spot, according to observations with NASA's Hubble Space Telescope. The Little Red Spot's winds, now raging up to approximately 400 miles per hour, signal that the storm is growing stronger, according to the NASA-led team that made the Hubble observations. The increased intensity of the storm probably caused it to change color from its original white in late 2005, according to the team. So it shows Jupiter's red spots right there, okay? Credit NASA. ESA Amy Simon Miller. That's her photo there. Okay, so although it seems small when viewed against Jupiter's vast scale, the Little Red Spot is actually about the size of Earth. And the Great Red Spot is around 3 Earth diameters across. Both are giant storms in Jupiter's southern hemisphere powered by warm air rising in their centers. The Little Red Spot is the only survivor among 3 white-colored storms that merged together. In the 1940s, the 3 storms were seen forming in a band slightly below the Great Red Spot. In 1998, 2 of the storms merged into one, which then merged into the 3rd storm in 2000. In 2005, amateur astronomers noticed that this remaining larger storm was changing color, and it became known as the Little Red Spot after becoming noticeably red in early 2006. The new Hubble observations by the team revealed that winds in the Little Red Spot have grown stronger compared to previous observations. In 1979, Voyager 1 and 2 flew by Jupiter and recorded that top winds were about 268 miles per hour in one of the parent storms that merged to become the Little Red Spot. Nearly 20 years later, the Galileo orbiter revealed that top wind speeds were still the same in the parent storm, but winds in the Great Red Spot blew at up to 400 miles per hour. The team used Hubble's new advanced camera for surveys, instrument to discover that top wind speeds in both storms are now the same. Because this instrument has enough resolution to track small features in these storms, revealing their wind speeds, scientists are not sure why the Little Red Spot is growing stronger. These storms naturally fluctuate in size, and their winds spin around their central core of rising air. If the storm were to become smaller, its spiraling winds would increase the same way spinning ice skaters turn faster, by pulling their arms closer to their bodies. Another possibility is that it's the only survivor. The team could confirm exactly what the red material is if they were able to use a technique called spectroscopy in future observations of the Little Red Spot. Spectroscopy is an analysis of the light given off by any object. Each element and chemical gives a unique signal, brightness at specific colors or wavelengths. Identifying these signals reveals an object's composition. However, spectroscopy of Jupiter's atmosphere is complicated because it has many chemicals that could turn red if exposed to ultraviolet light. We need to simulate different possible Jupiter atmospheres in a lab so we can discover what spectrometric signals they give. We will then have something to compare with the actual spectrometric signal, said Simon Miller. The team includes Simon Miller, Dr. Nancy J. Chanover, and Michael Sussman of New Mexico State University, Las Cruz, NM. Dr. Glenn S. Orton of NASA's Jet Propulsion Laboratory, Pasadena, California, Irene Chazaris of the University of Maryland, College Park, and Dr. Eric Kravashka of the University of Arizona, Tucson. Bill Steigerwald, NASA Goddard Space Flight Center, from www.nasa.gov. Okay, so 2012, July 17th, AIRL says, it's red earth, the same kind you find on the moon in the orange soil. Cross-reference your chemical findings with the data and you will figure out what is causing the great red spot. Cross-reference, see next 3 videos, orange soil, Apollo 17, and volcanic glass beads.